our Topic 4 challenge, we were asked to build a bottle rocket that can reach the greatest height.
There are some constraints. We only have a certain amount of time to build, we have limited materials, and we can't poke holes in the vehicle because, well, it wouldn't fly. In order to build the perfect rocket, we have to answer 3 questions. How do we limit the weight? How do we limit air resistance? And how do we keep it moving upwards for the longest amount of time? In order to determine how much energy our rocket had and what type of energy it was, we needed to determine the height. And we found that by plugging the amount of time it spent in the air into a formula. That formula was d equals 1/2 gt squared. And using that, we got 16.2. Next, we found what energy was present when the rocket got rid of all the water. Next, we found what energy was present when the rocket got rid of all the water. We then found what kind of energy was present in the rocket when it had released all of the water. This was when it was about 2 meters off the ground. We know that the total energy is 16.68 joules. So, we can find the gravitational potential energy using the formula Eg equals mgh. Using this, we find that the gravitational potential energy is 1.6 joules. We already know that the dissipated energy is 4 joules because we were told this. Adding them together and subtracting them from the total energy, we'll get 11.08 joules, which is the kinetic energy. If we use the formula mass times 1/2 mv squared, we'll be able to find the velocity. If we plug it all in, we'll find that the velocity is equal to about 16.6 meters per second. We wouldn't have been able to complete this project without the laws of conservation. Because of these, we were able to find the total energy and know that it would be a constant. Knowing that it was a constant, we could calculate other values like the kinetic energy and use that to find the velocity. One question we have is, how did energy dissipate if the rocket didn't hit anything on its way up? But actually, it did hit stuff on its way up. It hit tiny air molecules, which slowed it down by creating friction. If we were able to change the rocket in any way, I would decrease the mass and I'd try to put more work into it before launching it so that it could go higher.